Hello everyone, and welcome to this next video in the Houdini Academy Foundation module. In this video, I want to start working on the floors that are supposed to sit in between the different elements of our building, in between the different wall tiles that we built over the last lectures. Next to this, I also want to build a basic collision mesh and make a start on integrating this for the Unreal Engine. So over here in our example file, what we are going to work on today is this section over here, and then we'll also add the bottom section down here. Now we won't be building every single thing just yet because we don't have our materials at this point. We'll deal with that later. But for now, let's get started and let's add the basic floors, the upper railing, and the collision. And then by the end of this video, we are going to bring it over into Unreal. So let's open up our scene and let's get started. Okay. The first thing that I want to do is work on the floors. And to do that, let's go ahead and create a new section down here, specifically for that. So let's zoom in. And I'm going to create a net box here in my screen. And this time I'm going to start with that, so I can decide where I want my network to be built, basically. Organize it beforehand. And I'm going to call this one Create Floors. Now inside this section, I want to start building my floors. And up here, in the first part of our network, we actually already have our floor plans, right? If you remember from the earlier videos, we built a basic shape, which included a center primitive, and then a lot of primitive lines around the edges. Now we use this to extrude our walls, but we can also use it to create our floors as well. So let's grab a line from this. And the first thing I want to do is filter out this center primitive. So let's create a blast node for that. I'm going to drop it just above our net box because later on I'll actually need it to pull data to other parts of my network as well. Now what I need to filter out is the edge group that comes with our mesh. So we get rid of those primitives on the edges. So if we get rid of those, let's color this node red. And let's call it the isolate floor plane blast node. So with this, we have our basic shape, and now let's go ahead and use it. So let's go ahead and pull a line from our blast node, and let's add a poly extrude. Now this poly extrude is going to be my poly extrude floor depth node. But I'm going to add temp to it because this particular node is going to be a temporary node. We are going to replace this poly extrude and several other ones later when we are going to texture our building. So here you can see that I have my current poly extrude that I'm building now. And then I have a specific node, a utility asset that we are going to build later on. And this one's going to texture our geometry at the same time. So we'll deal with that later in the course. For now, we are simply going to grab this node and I'm going to use it to extrude my surface up. Let's give it a depth of 0.3, right? And also let's make sure that we have the back, because by default the poly extrude does not extrude the back. All right. Now, if you might recall, the default version of the poly extrude, the distance value here, it extrudes based on the mesh normals, the vertex normals of the plane. Now in our case, these are pointing straight up, so this is pretty secure. But if you do want to be sure that you are pointing in a very fixed direction, you can always use transform front right here. And then just set it to global mode and then use the translate Y channel instead. In fact, you can combine these if you want to. In this case, let's keep this off. And there's one other thing you need to know before we continue, and that is that this floor that we're adding right now, this layer, is going to sit in between our tiles. It's going to sit in between the tiles of our building. And it's going to eat away at the available space in our building. But you do need to remember that if you make your floors too thick, like so, then as they get copied up the building, there simply won't be any space left. So in that case, you would have to go to the floor height and increase that one too. Now, I'm currently not going to link these two up, but if you want to do that later on, after the project's done, feel free to make any changes you want. And of course, if you want, you can always go to the Houdini Academy Discord channel and show your project there, right? So I would love to see what you come up with. Now let's set this value to 0.3 and let's go ahead and add this to our interface. So let's open up our type properties. So let's go ahead and pull the distance value over here and let's plug it in below our floor height, right there. And I'm going to call this the floor depth. And this will then control the depth of our floors. Now, I do want to make sure that our floors can't get too thin. So let's lock it at 0.1. And I'm going to keep the maximum at 1, but unlocked. Now, as for the default value, let's make sure that this is actually 0.3. Like so. And with that, let's go ahead and accept that. So now, under our parameters panel, we should have the ability to control the thickness of our floors. All right, nice. Okay, so next let's go ahead and copy this floor up our building, right? And this is very similar to what we did before. I'm just going to change my layout again. And what we have here on the left is the copy node that we used for our walls. And this one, of course, copies our walls up. So we're going to use the same type of node right here. In fact, let me just create a new one. Let's create a copy and transform node. And I will call this one copy floors. And let's plug that in. Now, as for our settings, all we really need to do is specify how many floors we actually want to have. So we can grab our parameter panel, grab our floor count, which is over here, copy that into our total number, and then grab our floor height and plug that into the translate y. And now, as you can see, we do have our floors for the building, but we still don't actually have the roof. So let's add one extra floor on here, so +1, and that will give us a roof as well. Now at this point, our floors are basically flush with the tiles of our building, and I want to add a little bit of flair to them. So let's go ahead and add a trim to the edges of our floors as well. And we can do this fairly easily. Let's go to our poly extrude and let's look at the floor down here. And down in the group section, I'm going to add a side group. Now, if I visualize my groups, you can see that we have a group on the sides of our extrusion. We can then use that to extrude from there again. Now, I'm going to call this one the side group. And then I'm going to add a new poly extrude node right behind that. Let's call this poly extrude node the poly extrude trim. Now, in this case, when we look at our normals, you'll notice that our normals are actually pointing sideways now. Like I mentioned, the default distance behavior of the poly extrude translates along the normals of our mesh. Now, what this means is that if right now I change the distance value, I'm basically extruding the entire mesh. Well, in fact, what I'm actually doing is it's more like I'm scaling it up along its normals. If I want to make sure that I'm only extruding the sides, I just have to provide it as a group up here. And now, if I use the distance value, it's only going to extrude it along the edge normals, the normals of the side group here. So we have the ability to add a little extra edge to the side of our building. a basic trim, right? So let's go ahead and hook that up to our interface as well. So we have the control for our trim depth. Let's open up the type properties. Move this over again. And under here, under wall thickness, I'm going to drag over my poly extrude trim distance value. And let's plug it in right there. Let's call this the trim thickness. Now, as for its values, let's go ahead and lock it at 0.01, so it can never be perfectly zero. I want to avoid creating perfectly thin geometry or have it not generate geometry at all. And then under channels, let's go ahead and set it to 0.2 or 0.25. Let's go ahead and apply that as well. And now I should have the ability to control that from my interface as well. Yeah, so now I can add some trim to the side of my building, and that all works fine. Okay, so at this point we now have our floors, we have our trims, and if we copy it up the building, then we now have a nice edge that should fit in between our tiles. Now next, what I would like to do is just clean up our mesh a little bit more. Because right now we do have all these edges and points that are still in between the corners of our mesh, and this is a little bit much. We don't actually need them to be there. So in order to clean those up, we can use a facet node for that. And the facet node, and let's drop this one right here, allows us to take the edges that are coming from our floor plane and clean up any points that are in between our corners. So if an edge is too straight, we can clean it up using remove inline points right here. Now if we set the value here too high, then it's basically going to start collapsing our surface, so we don't want that, right? But at the default value of 0.001, this is quite secure. Now the facet node has a lot of other functionality as well, and I'll quickly go over that. So let's go ahead and create a torus. And if I look at that torus, then by default, if I keep my view in shaded mode, right, so we can see the normals of our meshes, you can see how this particular mesh has pretty smooth normals. Even though we can see the wireframe, it looks like it's round. And if I remove the wireframe altogether, then it looks like a proper round donut, right? Now that's because the normals on this mesh, if we look at the normal display, are all pointing in the same direction. And that's how polygon shading works, right? Basically, the direction of the surface and the normals on that surface determine the shading. Now we can use a normal node to change the behavior of these normals. If I grab a normal node, plug that in, and let's say I use the vertex normals here, I can then go ahead and cusp the normals. Let's make sure I also look at the point numbers at the same time. If I lower the normal angle, then at some point you're going to start seeing the torus facet based on the angle on this shape. So see how it now has these bands going around? And that's because when this torus is created, some of these angles are sharper than others, and that creates this difference in how it is shaded. Right now the normals are broken, and you can see that here. It basically splits the normals of the vertices in either direction. So that's what vertex normals do, okay? They basically allow us to see our mesh in a smooth or non-smooth way. Now the reason that I'm showing you this right now is to demonstrate how the normals of our mesh have a big impact on how our mesh looks. And we'll be dealing with this later when we have to bring our mesh into Unreal. Now the normal node is not the only node that has the ability to manipulate our normals. The facet node also does this. So if I create another facet node here, and I plug it in, let's say below our normal node, the facet node has the ability to recompute our normals. So right down below, we have the ability to post-compute our normals. When we do that, it's going to take the shape of our surface and it's going to recompute it. And it's going to recompute it based on the actual shape itself, like how the points in the shape are connected. And it's called post-compute because the facet node can also break our connections based on an angle. So if I turn on cusp polygons, then now it's basically doing the same thing as our normal node did before, except instead of manipulating the normals, it has basically broken our mesh into ribbons. I could actually go ahead and select some of these primitives and simply pull them out. And you see how they're no longer connected, whereas before they were. So that's basically what the facet node can do. It can manipulate your geometry and recompute your normals accordingly. So I wanted to show you this so you have a better idea on what this node can do, and also have a better idea of normals before we start dealing with those later. Okay, so now that we've basically removed the extra detail in between our layers using the facet node, let's clean up our mesh just a little bit more by adding a divide sop in between. So right now we have these very big n-gons, and n-gons basically just means polygons with more than 4 sides. Okay, so more than 4 vertices inside of them. And I want to clean them up. So we can use a divide node to triangulate this mesh. Let's create a divide sop and plug that one in. And by default, the divide sop is going to triangulate our mesh. But when you want to do this properly, I suggest you turn on don't generate slivers and also avoid small angles. And this will make sure that it will try to create as large a triangle as possible, so you don't get really tiny slivers in your meshes. This generally works better with game engines, and it generally makes better models overall. So whenever you use the divide node to triangulate, just turn on these two options. Now, the divide node does have other features as well. If I go ahead and turn off the convex polygons option to disable the triangulation, down below here we can turn on Bricker, and this will cut up our mesh using a grid-based cut that we can control. Now, personally, I find this to be very heavy. There are other ways to, cut up your mesh into slices like this, but this is one option, one way how you can do that. And then down below here, you can remove all the edges that are shared. So if we have a mesh, for example, that is open, like a grid, and we plug in a divide node below that, and then we turn on remove shared edges, it is going to remove all the edges on the inside of our mesh. So this can be pretty useful for that. In a way, it basically just keeps all the outer edges that don't have any polygons connected on the outside. Now, as for our divide node, let's keep the convex polygons function on, and let's call this one the triangulate floors. Now that we have our meshes, I would like to add a little bit of extra detail to them to give a little bit of cusping to these edges. Because right now what we have is a very sharp polygon mesh, and I want to change that a little bit. So what we can do is we can add a bevel node behind this to add just a little bit of extra detail. So let's go ahead and pull from the copy floors node, and let's add a bevel node right below. Let's add a poly bevel. And the poly bevel in Houdini allows us to take any edge with a certain angle and bevel it. Now by default, if we use the bevel feature right here, the distance value, it's going to try to bevel everything. And in general, this doesn't look particularly well. Also, it might cause a couple of issues if you bevel too far. So what I want to do is go over here to the top and use the exclusions option. Then turn on ignore flat edges. So any edge that is basically a flat edge that doesn't have an angle is not going to be beveled. And then we can control the angle for that right here. Now I'm going to leave this at 2%, that's fine. And as for the bevel strength, let's set this really low. Let's set this to 0.005. So these edges are going to be more felt than actually seen. But this is going to play really nicely with some of our normals for Unreal. So later on we have more smooth edges in Unreal. Now we don't need bevels per se, and the bevel node is prone to break if you feed it problematic geometry. So in some cases in our project I'm going to use them, and in other cases I am not going to use them, depending on the safety of our geometry. In this case I think our meshes will be fine. They're probably not going to break in this case, so we're going to use them here. And the last thing I do want to do though is add just another divide node in here, because we did add additional geometry, and just in case I'm going to retriangulate right below and push it below my bevel right there. And the reason I'm doing this again, basically up here and then again down here, is because I want to be able to copy this network later on, and up here I need this triangulate later when we start cutting the holes for the different floors of our building. But don't worry about this for now. Basically right now let's just go ahead and grab these nodes and put them inside their own little netbox. And we'll call this network the bevel and clean. So we can copy this network later when we need it. Next, what I would like to do is grab these parts of my network here and combine them with our outer tiles. So let's grab a merge node. And I'm going to place this merge node down here in my network. Then let's go ahead and grab my outer tiles right here directly from the loop. Plug that into the merge node as a first input. Then let's go over here, grab our triangulate node, pull a line from that, and let's merge it together. Okay, so now we're starting to see a basic shape in our building, right? And it's starting to look quite good. At this point, we still have a couple of things we need to fix. For example, our tiles are not actually sitting in between our floors. They're still intersecting with our floors, and that's something I need to adjust. But other than that, this is already starting to work quite nicely. So let's go ahead and name this merge node, because we're going to be merging other stuff in here later as well. This is going to be the merge visible mesh components node. And let's give it its own netbox. So let's click on the netbox button. Drag that out a bit. Let's make it suitably big, because we're going to put some other stuff in here. And I'm going to call this one the meshes output. This is where we're going to take all of our meshes, process them, so we can send them to Unreal. Okay. Now I mentioned how we need to make sure that our tiles are sitting in between our floors. Now we do have our floor depth already, and we can control that. But I do want my windows and my doors down below to scale to this. So let's go over here to where we have our tile frame, and I want to make some basic adjustments. Basically what we did before is we hooked everything in this network up to the size and bounding box of our tile frame. And this means that if I go ahead and adjust the shape of my tile frame, all these other components are going to actually shape along with it, right? We made sure that all these nodes are linking to this one. So what I can do is, let's first make sure that these tiles here subtract their own height, their floor height, with the floor depth. So let's grab the floor depth value, go over here to the size Y channel, and let's say floor height minus the floor depth. Okay, so now you can already see we're basically reducing the height of our tiles, so that's working, but there's still a gap. So let's raise them up as well. Let's go over here to our center offset and let's add half the floor depth to that as well. So plus the floor depth and then multiply that by 0.5. Now, because of, again, math priority, multiplication comes before addition, so technically we don't have to add this inside brackets, but just in case, I always like to do this to make sure that if I ever mess up my equations, I know that whatever is inside of a bracket will be calculated first in its own little section. This will also be calculated in its own little section, and then they get added together, right? So we first have the floor height for the tiles, for their offset. Then we have the floor depth. We add those together, and that gives us the actual height of the tile. Basically, it's just to make sure that our math doesn't mess up on us. So now that we have our tiles in between our floors, let's add a little bit of color to our floors themselves. So up here under my floor section, let's add a color node right here. And as for the color itself, let's go ahead and make it something grayish, maybe not too dark, maybe like 0.5 could work, right? Okay. This is going to be a point color for now, and it's important that you make sure that whatever color you're applying to your mesh is going to be the same type, because you're going to get competing color attributes in your system, and if you have primitive color and point color, then they're going to compete. So if I grab my color node here and I switch this over to primitive mode, you're going to notice that we still have our windows colored blue because those are point color, but the primitive color that we just set is gone. And that's simply because down here in the merge node, the output in my visual, in my screen, has to compete between the point color and the primitive color. And well, point color wins over primitive color. So it's always a good idea to make sure that whatever color you're assigning is the same attribute type, right? So let's switch this back to point color. Make sure that we're only having a point color here in the end. Now, when it comes to cleaning our network before we send it into Unreal, there are a couple of things that we need to do, a couple of steps that we need to take to make sure our mesh is proper and ready. But I think it's better to just show you why we need to do this, and then we'll clean it up in the process, right? So let's get this mesh ready to send it to Unreal. And the first and main thing that we need to do is create an output node. So we always make sure that this part of the network is going to be output to Unreal. So let's press tab and create an output node right here. This is output 0, and this will make sure that whatever comes out of this network is going to be rendered right there. Then let's go ahead and save our tool, save node type, and let's go ahead and open Unreal. Okay, so over here in Unreal, let's bring in our asset, right? So over here I have a little area set up. Let's open the HDA folder for our tool, and then let's drag it into our content browser. And then from there, we can simply drag it over here into our scene. Now you can see that by default, the tool is not going to generate floors. So we have our tiles like this. That's fine. Let's go ahead and grab the orange dot and let's drag it out. Okay. And then let's go ahead and hold Alt and drag the line a bit further until we have a nice square building, or well, any building that we want to draw. Let's give it a little bit more detail. Yeah, something like this will do. Okay, so here we have a basic building, and well, we do have a couple of problems going on here. In fact, if we go ahead and click play and we approach our building, well, right now we don't seem to have a floor. Our doors have issues right here. Our normals are all messed up. And, well, just in general, it doesn't look very good. So let's go ahead and clear this up, okay? Because we have a couple of bugs that we need to fix. See, the point you drop a tool from Houdini inside of Unreal and you build it in a different kind of environment, that's when you're probably going to run into issues. You know, the same thing is going to happen when you try to use your tool inside a different scene file in Houdini and you build it a different way, or you hand it off to someone else and they have a different method of drawing the building. That's when you're going to start running into problems. So it's always a good way to test if your tool is actually breaking or not, because what we built here is very consistent. We've built it in a certain way. We have a very, secure environment, a very fixed environment that we're always saving and loading our scene file. So things aren't going to break on us. But the moment we bring it over somewhere else in a different kind of environment, and it will break on us, well, that's when we can figure out what's actually going on. Okay, so the first issue that I want to deal with right now is why our floors are pointing downwards and not upwards. If I look over here, we can see we have all these gaps, and that's simply because our floors are not extruding up, but instead they're extruding down into the ground or into the tile below, which is wrong. And I thought we fixed this, right? We created our system in the very first lecture to make sure that if we drew a plane in the opposite direction, it should always be facing up. So something must be broken there. And we can quickly test this if we just grab another building and recreate the situation, but instead of drawing our curve in a clockwise direction, let's draw it in a counterclockwise direction. Let's grab the curve, drag it out, hold Alt, and here we go. Okay, so here our building is actually working properly. So it is the drawing order of our curve. Okay, so now we know that that's the problem. Now, in order to recreate our scene, we can actually open up this scene in Houdini. If we have our scene here in Unreal and we have a problem, we can go to the Houdini Engine tab, and then we can say save Houdini scene to a HIP file, and then we can load that HIP file in Houdini, or we can simply open up this scene directly in Houdini through this button. Now, I'm not going to do this right now because I don't want to load every single model, including this building, into my HIP file, but yeah, it's there if you need it. Okay, so back here in Houdini, let's go ahead and replicate our issue. Let's go to the object level and go to our building drawing curve. Now, right now, this curve, if we look at the point numbers, is drawn in a counterclockwise orientation. And if we turn this into a surface by closing it, then by default it's going to point downwards. Okay, that's because of the vertex order. I can show the vertex order if I press the D key, and then under the markers I can turn on vertex numbers. And now you can see that for every point number there's a vertex, because this surface here has vertices on every corner. Now it's currently 0 to 0, 1 on 1, 2 on 2, 3, 3, 4, 4, and 5, 5. Okay. Now if we go ahead and either draw this curve in the opposite direction or we flip it here using reverse, we're going to reverse the vertex order in the opposite way. And this of course will cause the surface to be pointed up instead, even though our point numbers are drawn in the original counterclockwise orientation. Now let's go ahead and keep it reversed, but I'm going to remove close. Okay, so we still have our clockwise vertex order right now. And then let's go into our tool and see what's going on. Well, let me hide all these numbers. But okay, so we can actually see that we have the same problem now in Houdini as we had in Unreal. And this makes sense because it's running on the same tool. If you have a problem in Unreal it will also happen in Houdini under the same circumstances. Now, like I mentioned, in Unreal, you can go over here to the Houdini engine tab and then go down here to get the scene file directly from Unreal, so you can replicate the exact situation. But yeah, as long as you have that situation, you can go and debug your problem. Now in our case, I know that the problem originates from the curve being reversed. So our flipping system is broken. Let's go ahead and have a look at that. So here we have our curve, and currently it is pointing up. And I just want to see my normals a bit better. So I'm going to go to the D menu, go to Guides, and then I'm going to increase the size of my normals a bit. So this allows me to see them better. Next, then here we have our flipping system. The first part groups our plane if it's upside down. Now right now it's not, so we are not assigning a group. This mesh here is not grouped. Okay, flip group is 0. As a result, our reverse node here shouldn't actually be flipping the vertex order. And yet it is, because, and that's my mistake, I forgot to set the group. Okay, now I did fix this in the editing of the video, so you probably have fixed this problem yourself already. But then let's go ahead and check if this fixed our problem. Let's have a look. And, well, it turns out we didn't actually fix the problem. There's apparently another bug in here that we probably introduced with our new fix. Or rather, our fix exposed another problem. Okay, so let's go ahead and fix this right now. This is still a good opportunity. It's bug hunting time. Okay, so let's zoom out and let's go to the top and let's find out where this bug is actually coming from. So we know that we have our plane facing upwards, right? Everything is fine, our vertex order is correct. And we also have our point order right here. Now next, let's go down the line and look at where the problem seems to be originating. Now I think it's coming from the polyfill. And I think it's correct, because our polyfill is actually generating a plane that's upside down. And it's not supposed to do that. It's supposed to be pointing upwards, so that our poly extrude here can extrude upwards, and it's currently downward, so it's extruding down. So why is our polyfill generating a reversed primitive even when we actually provide it with a upward primitive? Well, that seems to have something to do with the way how we are regenerating our primitive from our polylines. Let's have a look at that. So here we have our convert line node, and here we have the primitive and point order. Okay, then let's look at the vertex order next. And well, you can't really make it out because they're overlapping, but the moment I use my resample node here and I look only at the vertex order, you can see how the vertex order is not flowing in a clockwise or counterclockwise direction. It's actually flowing in, well, various directions. This one's flowing to the left, this one's flowing to the right, and that might be the cause of our problem. If we grab one of these carve nodes here on the side, and we go ahead and change its carving behavior, you can see how these lines are being built in various different directions. That means their vertex orders are also in different directions, right? You can see how the 1 at the end of each line is building outwards. So as a result, when it finally filters through to our polyfill node, it probably doesn't know which way to point, right? And in this case, the vertex order is being mixed because when we created our resample node, it didn't know which way to point. So we should fix that first. Now, how can we go about and actually fix this? Now, in order to provide the correct information to this, first, what you would need to do is go ahead and prototype a bit and try and test things out. Now, in my case, I already know the solution. And it's basically to make sure that the vertex order and the point order on our input mesh are the same. Because right now they're not. when we flip this curve upside down, we only reversed the vertex order. We didn't actually reverse the point order. And the resample node here actually uses the point order to rewrite the mesh and write new vertex order. So what we need to do is make sure that those two are matching before we feed it to the resample node. Let's go ahead and create a sort node. And the sort node allows us to resort our points based on a particular condition. In this case, what I want to do is I want to resort my points to match the vertex order right here. If I do that, you can see how my point order just flipped around to match that of my vertex order. Now, if I feed it to the resample node, now let's have a look at our carve node here. And we can see that it has actually flipped the order in which it's building these curves around. Before, this was in the opposite direction. And this last edge here is actually still pointing in the opposite direction as well. But I think this isn't a big issue, because if we go down to the polyfill, it will now have fixed the problem. And personally, if I understand this correctly, it is because the way how this node is looking at the first vertice in the plane, which would be point 0, and which way that one is pointing. And I think that's how the polyfill ends up rebuilding this mesh. It just assumes from the first vertices which direction it should start building in. And we had to make sure that the direction it was getting was actually properly set up. And because of our vertex order being messed up by the resample node, that was being broken, so we had to correct that. Now I know this is a little heavy, but it's important that you understand bugs, that you have to go through it, try and fix them, try and find out what's causing them, and then when you find out, there's usually a very simple solution, such as just one sort node in the right place, okay? It often takes a bit of time, but once you figure it out, you're golden, okay? You can fix your problems. Now let's test this out. Let's go ahead and go back to the end of our network. And let's go ahead and flip our curve again. And I'm going to show all my objects right now. So I have my other mesh, this one, visible. And let's turn off reverse. Okay, well, it's working. I mean, the doors are moving because the vertex order and the point order of our curve is changing, but at the very least, our building isn't inversing itself. So good, that's the first issue that we fixed. And I think this was the hardest one. So next, let's have a look at what else is breaking. So let's save this tool out, save it, and then we go back to Unreal. I'm going to get rid of this other building. Then over here, let's go ahead and re-import our tool. Let's right-click it, re-import. And then I can right-click on the tool and say rebuild selected. And if we do this, we cause the entire tool, including its interface, to be reconstructed. Recook won't do it. We have to click on rebuild when we re-import our tool. Okay, so now at the very least, we have our building with the floors correct. So that's good. Then the next problem that we're seeing is that our normals are all messed up. Okay, so we have all of our normals right here. Let's go ahead and fix that as well. So inside of our tool, down here at the end, right now we don't have proper vertex normals. And if you don't have proper vertex normals on your mesh, and we go ahead and look at this in a smooth shaded view, then you can see that the entire mesh looks a little bit like butter, you know, especially around these edges. It's not very clean. So we can fix that. And we can do that very simply using a normal node. Let's create a normal node here. Plug that in. And the normal node, by default, is going to create vertex normals. Okay, so that's the ones we actually want to use for our meshes. We don't want to use point normals because point normals don't store information about what I showed you before with these edges, right? If we use point normals, then this entire mesh will still look like butter. Except in this case we have beveled our edge, so we do have that extra detail here, right on the edges. But if we were to look at our bigger tiles like these, point normals will just turn them into this badly shaded, rounded look. And that's not what we want. This is a building, not a beach volleyball or something soft, right? So let's go ahead and switch it to Vertex mode. And this will already fix this to some extent. But we're still dealing with somewhat smooth and rounded curves. You can see how this gloss kind of makes this feel like a rounded edge. Well, that's because of the way how the weighting method is set. We want to set this to by face area mode. If we do that, then we will actually fix our normals. And it will make the edges on our mesh look a lot better, especially when we have a bevel on them. So let's go ahead and do this. Okay, so with our normal set up, let's go ahead and save our tool again. Then let's go to Unreal, re-import, click on the mesh, and rebuild. And now you can see we now have proper normals. And also along these edges, they also look nice and smooth. But the planes themselves, the surfaces, they're nice and tight. They're properly set up. Alright, cool. That's problem 2 solved. Now I did notice another problem when I was looking earlier at the mesh, and that is right down here. Our doors aren't properly moving along with the bottom of our floors. And that's basically something that we did in the last lecture. So let's go ahead and fix this one too. Down here we have the flatten bottom points for our doors. If I look at the door shape. And this node is causing these points to snap to the grid, right? We basically set this up so it flattens it down using the flatten function of the transform node. And that's fine, except that we moved our entire tile up, right? When we used this feature here, the floor depth. So to fix that, we simply have to move these points up to match the rest of the bottom of the door. Let's grab our parameters from here and grab the floor depth value, copy it, and let's go ahead and paste it in the translate Y channel. Now what this is going to do is it's first going to flatten the points down to the grid, and then because of the transformation order, it's gonna transform them up after that. Okay, so that should fix our doors. Again, let's go ahead and test this. We now have proper meshes over here. Okay, that's good. And now let's go ahead and save this and test it out in Unreal as well. Let's reload the tool, rebuild it. Okay, so that one's fixed too. So at this point, let's click on play and let's start walking into our building. And here we have a problem. One, we have problems with the collision, and two, the doors are too small for our character. So let's go ahead and fix that next. Okay, so the reason that the player cannot actually pass through the doors right now is because while the doors are actually 2 meters high, which is enough for the player to pass through, the player needs about 2 meters space, we're actually subtracting about 30 centimeters here from the bottom of our doors, because our doors take their height from the very bottom of the tile and our floor sits right on top of that. So if we were to increase the floor depth here to say 0.5, you can see how our doors actually get smaller. And that's the main problem. Basically, what we need to do is update our doors so they always take the floor depth into account. So let's go over to Houdini and have a look at that. Okay, so here we have the loop for the tiles of our building. And what I want to do is go over to the door section here on the left. Let's have a look at this. Now, at this moment, we are setting the upper bar height based on the bottom of our tile, which is actually at grid level. And as you can see, we are eating away from it with our floor depth, right? That's what we did earlier. But we do need to actually raise up the upper bar here a bit so it actually compensates for that. We can do this really simply by taking the bar offset and just adding the floor depth to it. So just copy the floor depth, and we're going to say the door upper bar offset plus the floor depth. If we do that, it is going to raise up our door, and that should mean that this is going to be 2 meters exactly. Now I do want to make a quick change because of this to the name that I'm using here of our door upper bar height, because at this point it's no longer really the height based on the tile position, it's literally the height of our door. So to make it easier to read for the user and not so confusing, let's go ahead and change this to door height instead. Open up our type properties. Let's find the door upper bar height. And I'm going to leave the original name alone, but I'm simply going to simplify the label. So now we have our door height right here. And if we want to, we can even go a little bit further and add a separator in between. So we are really segmenting this part of our network. Let's go back into Unreal, reload this, rebuild. And now you can see the doors just became a little higher. We can go ahead and play, and now, well, we should be able to enter. All right, cool. So that's another problem solved. Now we're almost done. There's just one problem left, and that is the matter of the collision mesh. Now you might notice that I can't actually properly enter the building, and that is directly related to the fact that we beveled this edge. And when you bevel an edge, it adds extra geometry to that edge, and it turns out Unreal has a couple of issues navigating this particular ledge here, at least based on the collision for the player. Now the player does have a step height, and that step height should be able to get up the 0.3 or 30 centimeter high ledge here, but with that bevel the player just can't do it. Okay, so we need to fix this, and one way to fix that is to actually fix our collision. Let's go back into Unreal, reload this, rebuild, and now you can see the doors just became a little higher. We can go ahead and play, and now, well, we should be able to enter. All right, cool. So that's another problem solved. Now we're almost done. There's just one problem left, and that is the matter of the collision mesh. Now you might notice that I can't actually properly enter the building, and that is directly related to the fact that we beveled this edge. And when you bevel an edge, it adds extra geometry to that edge, and it turns out Unreal has a couple of issues navigating this particular ledge here, at least based on the collision for the player. Now the player does have a step height, and that step height should be able to get up the 0.3 or 30 centimeter high ledge here, but with that bevel the player just can't do it. Okay, so we need to fix this, and one way to fix that is to actually fix our collision. So let's do that. Let's add a dedicated collision mesh for our building. Now the reason we need a dedicated collision mesh, like I mentioned, is because the default vertex collision that comes from Houdini isn't gonna work. And when I say default, that's actually not quite true. Right now, in this version of Houdini, in this version of the Houdini engine, that being, let's see, Unreal Engine 4.26.2 and Houdini version 18.5.596, there's actually a bug in the Houdini engine that causes all the meshes generated by Houdini to have collision by default. And that shouldn't be the case. In previous versions of the Houdini engine, it actually didn't do that. Meshes shouldn't have collision by default. And in the current documentation of the Houdini engine, it also states that you need to actually set a group on your geometry in order for it to have collision to begin with. Otherwise, the player would just walk straight through it. If you want to check out the documentation yourself, you can simply go to Google and search for Houdini Engine Unreal. And then I think it's the first entry or the second one here, the documents. And then in here, you can find a lot of information about the Houdini Engine implementation for Unreal. Now I'm looking for the collisions section right here. And in here, it basically says that if we want to create complex collisions, meaning the type of collision we're looking for, the one that matches our building, we can use two types. Collision geo, which will create a geometry collision that is invisible, or rendered collision geo, which will add a collision to whatever is visible in your scene. So the mesh itself, right? So you would have a visible mesh, an invisible collision mesh, or have your visible mesh act as your collision mesh as well. And right now it's always defaulting to this one, okay, the right one. And we don't really want that. And there's ways around it as well, and I'll be using that during the course. But I do hope this bug gets fixed soon, because it's not really a good thing to have it always generate collision. There are times when you wouldn't want this, but you know, we have to work with bugs. Sometimes they exist, and hopefully it will be fixed in the future. So for now, let's go to Houdini, and I'll explain to you how it's supposed to work. And then as you follow the course, hopefully this bug gets fixed and you won't have to worry about it anymore anyway. So over here in our tool, what we want to do is I want to set up two types of collision for a mesh. Now the first one is very simple. And like I showed you in the documentation, it's called rendered collision geo. Okay, so let's go ahead and create a group node. And I'm going to plug it in right before the ending part of my network. Right there. And I'm going to call this one lowercase, everything lowercase, rendered collision geo. And then I'll add a UE4 actually. Now the reason I put this entire thing in lowercase is because that's the actual group name that Unreal's expecting. It doesn't want capital letters, it wants everything to be lowercase. So we're just going to call this one rendered collision geo. And I'm going to color this node yellow, just so I can differentiate it later. Something like that. Now this is a primitive group called rendered collision geo, and if this is present on your mesh, like this, then Unreal will pick this up, assuming we're not dealing with this bug I mentioned, as a complex as simple collision type, or basically per vertex collision. Every single part of our mesh, every single vertice is going to act like a vertex for your collision mesh. You're basically using your visual mesh as your collision mesh. And like I mentioned, the player can have trouble with that, so I'm going to leave this as an option, but this is not going to be the way how we're going to be dealing with it for the final tool in its default state. Okay? So let's go ahead and create the other collision method. And for that, we need to go ahead and collect some elements from our scene so we can make a lightweight collision solution. Now in this case, what I want to do is go over to the various parts of my scene and add a little bit onto it that we can extract from so we can have our collision. Over here we have our tiles, and these are already quite good. I didn't bevel these, so they're already low res, so this will work fine. Let's go ahead and add a null node right here. Move this out of the way. And this is going to be an output node that I'm going to reference from. I'm going to color this one dark gray, and I'm going to call it out, collision 1. Okay, now let's go ahead and copy that node and let's navigate up the network a bit. And the next part that I want to grab from is going to be up here below my copy node where I have my color. So I don't want to go to my bevel because that one actually adds the extra detail we don't want in our collision mesh. We want to go up here where we still have our floors in a very simple low poly state. And they have been triangulated as well. Let's add the null node right there. Plug it in. And then what I want to do down here is add an object merge. Now we've used the object merge before for the inputs, but we can also use it inside of our network to just grab data from all over our network and collect it together in one place. Kind of like a regular merge node, except without the need to wire it in. Instead it will use our references, our node references as the wires. Now I'm going to call this one in collision, and I'm going to color this one gray as well. And now we need to go ahead and grab the references from these nodes. So on the object merge, let's go to the first object, browse, and then I'm going to filter out inside here everything that starts with out collision. And this will grab all the objects in my scene that right now have this tag, so both these null nodes. So adding this prefix actually helps you find those easily. And I'm going to select the first one. Make sure it's in relative path and then accept. Okay, so that now has imported my walls. Next, let's click the plus button up here, add a new entry, and I'm just going to copy this and set it to 2 as well. So now we have both parts of our meshes, the low-res versions, imported right here. Now next, let's go ahead and make sure that this mesh is clean. Okay, because it's a collision mesh, I want to feed this to Unreal. Let's make sure it's proper before we do so. So the first thing I want to do is go ahead and clean some of my attributes and my groups, because I do have some on here. If I go to the info button, we can see we have point groups, we have primitive groups, we have all these attributes, and we need to clean all this up. We'll also need to clean it up for our main channel as well, but we'll do that in a moment. So let's create an attribute delete node. Plug it in below. And I'm going to call this one clean attributes or clean attributes, right? And I want to delete every single attribute on this mesh. Now, besides the point position, we could get rid of every single thing. So let's just type an asterisk symbol for that, and this will get rid of all this information. Next, under vertices, we have our UVs for our textures here. We don't need those either. So let's get rid of all of that as well. Then under the primitive attributes, we have our width attribute from above, and also the material that was assigned for these windows here. Again, let's get rid of that. And finally, well, we don't seem to have any detail attributes, but I'm just gonna filter that one out as well. So it's always a good idea to quickly look through what attributes you actually have, and in case you need to keep some, you can always add a exception to the rule by typing a hat symbol and then typing, and the attribute name basically. And that will filter it out from the selection. And next, let's create a group delete node. And let's call this one clean groups. Same story here. Let's go ahead and remove every single group as well. So now if we look at our info panel, there's no longer any data on here except our point position. So that's good. Then next, let's go ahead and do a triangulation on this mesh, so everything is triangulated. Before we triangulated the roof, but we haven't actually done so for our outer wall tiles. Now Unreal will triangulate our meshes, but it's always good to triangulate meshes properly before you feed them. So let's go ahead and grab a triangulate node from upstairs and plug it in right there. Okay, so that's good. We have our mesh ready. Now we need to add our group. So I'm going to go ahead and copy this group node, plug it in, but I don't actually want my collision mesh to be visible. Okay, so let's go ahead and change the group name. We're going to change that to collision geo, just like how it said so here, right there. It's a prefix, so you can actually create multiple collision geos, I believe, if you add a different name behind it, like collision geo A, for example, and collision geo B. I haven't tested this, but I believe that's what the documentation says. Then let's also update our name down here, so we keep it nice and organized. And so now that we have our collision geometry, let's go ahead and combine it with our mesh. Let's grab a merge node. And what I want to do is grab my original mesh, the one that I want to have that has all the detail, but won't provide the collision mesh. Plug that in. And then we're going to grab the collision mesh on the right, grab that one. And just to keep it clean, and this is a slightly older method, I don't think it's necessary anymore, but basically I want to add a group here, and I want to call this group the mesh group. It's just so I have a different group dedicated for my mesh right here, and the other one is the collision geometry. Then I'm going to call this merge node merge collision with mesh. And then finally, let's go ahead and add a switch node so we can flip between our rendered collision geo and our dedicated collision mesh. Also, you'll notice that now in my screen, these two are overlapping. Don't worry, this mesh will be invisible inside of Unreal. So the switch node, I'm just going to call it the collision switch or collision mode. And let's promote this one up to the interface. So let's grab our type properties. And then under our setup tab, what I want to do is grab my switch node, grab its value, and then I'm going to change this to an ordered menu. Then let's go ahead and call this the collision mode. And inside of our menu options, I'm going to set this to 0. And the first name is going to be the visible collision mesh, or visible collision only. So this option will only load our rendered collision geometry. Then the second option is going to be 1, and this one's going to say include dedicated collision. Okay, so with that, let's go ahead and accept that. And now we should have the ability from our interface under setup to flip between our two collision setups right there. Now we're still seeing that highlight flag from the group node because nothing has actually manipulated the geometry in between. This switch node is just feeding through the data. So let's go ahead and add a couple of extra nodes in here just to clean up some of these things. Because right now we still have some of the other groups and attributes. We actually did clean up our collision geometry, but we didn't do it for our main geometry. So let's do that as well. Let's grab this clean attribute node and let's plug it in below our normal node right here. I'm going to grab this network and just plug it in below. And as for the values on this node, well, we do actually want to keep some of our attributes. For example, under point attributes, we want to make sure we keep the color information. Now we can do that by, like I mentioned, typing a hat symbol, and then we can say cd color. Now it won't ever delete the point position, so we don't have to specify that one. But then under vertex attributes, I want to make sure I keep my normal and I keep my texture, my UVs. So let's also add those as exceptions. So hat symbol N and hat symbol UV, lowercase UV. That should fix that. Now the last attribute that we need to accept out is the primitive attribute for the shop material path. And this attribute is actually necessary to assign our material, because right now you can see we don't actually have a material on our windows. Let's add an exception for this attribute, and you'll see how now it actually keeps the material. And that's because in the primitive attributes, the shop material path leads to the UV quickshade node over here, and inside the UV quickshade node there is a shop network or a shader operator network which contains our materials, right? The actual material that we're loading here. So with that, we now have the attributes cleaned out. And the last thing I just want to do is make sure that I also clean out the groups, right? So we clean them up out here. Let's clean them up down here as well. Now I do want to keep a couple of my groups, actually. Specifically, I want to keep the mesh group. So let's add that one. Let's see, it should be a primitive group. Right, we're currently looking at this one. So this group delete node is not going to pick it up. Let's switch it over. The one with the collision. So let's add the mesh group as an exception. Then let's also accept out the rendered collision geo and the collision geo. All lowercase. Okay, so with that, we have now cleaned up all our data. Let's go ahead and save this out. Save node type. And let's go back to Unreal and let's have a look at what this did. So we're going to re-import, rebuild, and let's click on play. Okay, so right now we are still using our regular per vertex collision. So let's go ahead and click on the tool, go to setup, and then under here we find visible collision only. Let's switch that to include dedicated collision. We'll change this to the default in a second. Now if we try to play, there we go. So now our player is not having any issues walking up this little step, right? Because now we actually have a very simple collision box that is preventing our player from walking through the walls, but it's also, you know, allowing him to step up these steps. So that's great. So now we have our basic building done. I still want to add the little railing on the top, and I can do that really quickly. So let's do that, and then let's wrap up this lecture. Okay, so let's go back to Houdini, and over here inside the create floors network, let's go ahead and create a little offshoot. I'm going to grab the data from the facet node, pull that off, and then let's add a transform node here. So I want to create a railing on the top of my building. So let's have a look at the wireframe again. Let's raise this up to the very top, and we can easily grab that information if we grab the bounding box of the highest point of our floors. So here are our floors. I want to make a railing sit right on top of that. So let's grab this transform node. Let's call this one raise to roof. Then let's go to the translate Y channel and let's simply write a bounding box expression. I'm not going to bother with spare inputs right now. I'm just going to use a direct link. So within quotation marks, we'll type // copy floors. And this is copy floors 1 specifically. Then we have to type a comma. And then we need to specify what type of dimension we want to grab the bounding box information from. So that will be dimension y and then max for the maximum value. And this will return the exact position of the highest point of our building. So now we have our plane sitting on top of our building. So next, let's go ahead and add a poly extrude. Zoom in a little bit closer. And I'm going to call this one the inset railing shape. Now for this, I'm simply going to grab the wall thickness from over here. And then inset inwards my building, my plane. Now lastly, let's go ahead and remove the front side. Now next, let's go ahead and add a poly extrude behind. And I'll call this the poly extrude roof railing. As for its height, let's set this to 1.1. Seems to be about a right height for the player, right? As a railing height. And I also want to promote this to the top level. So I'm going to go to type properties. Then over here under balconies, I'm just going to grab this and drag it in there. We'll sort this out later. Let's call it the railing height. I'm going to lock it at 0.1. And as for its maximum height, well, let's say we don't want our railings to be higher than 2 meters. Something like that. Default value 1.1. And let's accept that. So let's grab this. Let's wrap it inside of a netbox as well. And I'm going to call this part the create roof railing. Then next, let's go ahead and add a dedicated collision for this one. So I'm going to copy my out collision 2, paste it in here, and then go down below to our collision node, and I'm going to add a new entry. So you can see how this is going to work, right? We add a new element, and we add the collision right there. So now we have it added for our collision. Let's go ahead and add it to the rest as well. So here's our railing. Let's grab the bevel and clean section down here. Copy that. Plug it in. This will add some nice edges to our railing. I'm also going to add a color node to this as well. I don't really care if it's above or below. That doesn't matter too much. But I am going to make it, say, somewhat grayish, maybe white, like this. And then let's go ahead and plug this down below, right here, into our merge node. So now, if we feed this through our network to the very end, we save it out. Let's go ahead and reload this. So now we have a railing on top of our building. And if we drop the player on top, there we go. We now have a basic building all done. Now you know several different important things about taking a tool from your Houdini scene and bringing it into Unreal. And especially the problems that you might run into when you're doing this, right? So we've created a basic set of meshes. We had to clean them up, make sure we had clean attributes. We had proper normals. We had collision set up properly, and we cleaned up our groups. So that's one thing. 2, we checked through our network, make sure there were no bugs, that all our values were set properly. In fact, before I forget, let's go to the type properties, go down below, and switch our default collision for Unreal to state 1. So that will be our dedicated collision mesh. Okay? So the moment we import this into Unreal, we'll be able to play with it right away. But okay, so at this point, in the next few videos, I'm going to start working on the staircases and the meshes on top of the roof. Now we're going to first start off with a more basic part of the network. We're going to create a basic interior grid that we need to assign our